SAT Math Lesson 10 is the last section of linear functions. Okay, so you'll have another group of examples here, followed by another small assessment. So the first example, it says in the xy plane, the graph of which of the following equations is perpendicular to the graph of the equations above. Well, number one, with perpendicular lines, you need to know that if you're given a line and it has a slope of a over b, the slope of the line perpendicular would be the opposite reciprocal, meaning if that's positive, this is negative b over a. So it's very important to know that perpendicular lines have slopes that are opposite, meaning sign flips, and reciprocals of each other. Now, with standard form, we've said many times before, you could solve for y, right? So I can take this and solve for y by adding 2x to both sides, plus 6, and divide everything by 3, and y equals 2/3 x plus 2, right? You can find the slope of the line real easily just by solving for y. But if you're in standard form, the quickest way to do it is just take the opposite of a, so the opposite of negative 2 is 2, and divide it by b, which is 3. So now, if the slope of this line is 2/3, right, if a line is perpendicular to it, it'll have the slope of the line perpendicular has to be the opposite of positive is negative. The reciprocal of 2/3 is 3/2. So right here, I'm going to go ahead. The slope of this line, the opposite of 3 is negative 3 over 2. Does that match up? Yep. So it'd be letter A. If I go and find the rest of the slopes, this slope would be negative 3/4. The slope of this line would be negative 2/4 or negative 1/2. And the slope of this line would be negative 2 over 6, which reduces to negative 1/3. None of those work. Okay, now this one is a pretty difficult problem, and there's one feature that you guys probably have not done a lot of, if at all, and that's a linear regression model. This is one, if you practice on the calculator and you understand it, it should be pretty reasonable. So first, it says the Townsend Realty Group invested in 5 different properties listed in the table above. The table shows the amount in dollars the company paid for each property and the corresponding monthly rental price in dollars. The company charges for the property at each of the 5 locations. The relationship between the monthly rental price R in dollars and the property's purchase price P in thousands of dollars. This is a key phrase here, and I'll explain why in a minute. Can be represented by a linear function. Which of the following functions represents the relationship? When it says in thousands of dollars, what they really want you to do is write the linear equation that suits this info using 128, 176, 70, 140, and 450, because this would mean it's in thousands, right? So what we're going to do, and again, if you understand the calculator, this is a real easy problem. What you're going to do is you're going to hit the stat button, and under here we're going to edit, and then you'll get a bunch of lists here. What we're going to do is in list 1, we're going to put the purchase price in dollars. So I'm just going to enter 128, enter. Then I'm going to do 176, hit enter. 70, hit enter. 140, hit enter. And then 450. Then I'm going to meant to hit enter. Then I'm going to arrow over and enter the monthly rental price right in here. So 950, 1310, 515, 1040, and 33 65. Now, once I enter both my lists, I'm going to hit the Stat button again, and I'm going to arrow over to Calc. And in this menu, if I look, I'm going to do number 4, which is a linear regression model. So I'll arrow down to 4, then I'll hit Enter, 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 and one more time. And right away, gives you A is 7.5, B is -10. And right up here in this equation, when you plug A and B in, you get Y equals 7.5x minus 10. And if you look, that ends up being choice D. So the next example, the graph of the linear function f, right? So right away you have to know that this is linear function f of x, okay, is shown in the xy plane above. The slope of the graph of the linear function g, right? So our new function g is 4 times the slope of the graph of f. So we know the slope of f, right, is something. The slope of g is 4 times that. So right away, I'm going to go up here and I'm going to calculate what the slope of this is. So I'll pick a nice point here, up 1 over 2. So the slope of this line is 1/2. So the slope of my new line g would be 4 times 1/2, which is 2. So it says if the graph of g passes through the point 0, -4, which I want you to recognize right away is the y-intercept, what is the value of g of 9? So we're looking to evaluate g of 9, which means we need the function. So we know the slope of our new function is 2, so it's 2x. And if our y-intercept is 0, -4, it's going to be -4. So now to evaluate g of 9, I'm going to input 9 in there. 2 times 9 minus 4 gives me 18 minus 4, which is 14. And that is letter C. So this is a problem that involves a lot of steps. Every step in this problem, though, you should be aware of. And it's always knowing what you have, knowing what you have to find, and knowing how to use everything. Next one. A musician has a new song available for downloading or streaming. The musician earns 9 cents each time a song is downloaded and 2 cents each time a song is streamed. Which of the following expressions represents the amount in dollars that the musician earns if the song is downloaded D times and streamed S times? Well, if you think about it, if I call D downloaded songs, S streamed songs, to figure out the money I make off the downloads, I would multiply 0.09 times D, and streamed, I'm going to multiply 0.002 times S. And the amount I make off downloads and the amount I made off streams, I would add them together to get letter C. Okay, so you're given this function here, and it says one end of a spring is attached to a ceiling. When an object of mass, right, kilograms, is attached to the other end of the spring stretches to a length of L centimeters, as shown in the equation above. What is M when L is 73? Well, if L is 73, what I'm going to do is just plug that value in. 73 equals 24 plus 3.5 M. Now, all I have to do is basically go ahead and solve for M. Subtract 24. 3.5 M equals 3.5 M equals 51. And now when I divide by 3.5, you would get M is 14. All right, which is letter A. That's a must-get problem. Okay, the next one. The graph of the linear function f has intercepts at A0 and B0 in the xy plane. if a plus b equals 0 and a is not equal to b, which of the following is true about the slope of the graph of f? Now, this is kind of like what I would call a T3 or tier 3 problem, meaning it's one that hopefully you can get, but it is going to be a tough problem. There's no way to really graphically show how this answer would make sense. You have to do it algebraically. And what I'm going to use is the slope formula, right, on the given variables. So I'm going to do y minus y, so I'm going to go b minus 0 over 0 minus a. And when I find the slope of this, I get b over negative a, and that just ends up being a slope of negative b over a. But here's the thing, right? A lot of people will jump and say it's negative, but you don't know that yet. You have to use the other constraint they give you. And the other constraint they give you is that a plus b is equal to 0. Now, if I take that equation and I choose to solve for, say, a, I'm going to say a is equal to, when I subtract b, it would be negative b. So now, when I go to substitute this value of a in here, I get negative b over, I'm going to replace a with negative b. That would simplify to 1. And if the slope of this is 1, that's telling you it would be positive. Okay? Again, pretty tough problem, but once you've seen it and you get stuck on something, you don't know an approach, think backwards to things you've done in these videos. Okay? So this one, again, tough problem. In the xy plane above, ABCD is a square and point E is at the center of the square. The coordinates of point C and E are 7, 2, and 1, 0 respectively. Which of the following is an equation of the line that passes through point B and D? Now, we need to find the line that goes through E and passes through B and D. Well, the one thing you have to know is in a square, diagonals are perpendicular. So if I find the slope of AC, meaning right away I'm going to use the slope formula here, 2 minus 0 over 7 minus 1. That would give me 2 over 6, which is 1/3. So if the slope of AC is 1/3, I know the slope of BD, right, is going to be the opposite reciprocal. So I'm going to take the opposite of 1/3, which is negative. The reciprocal would be 3 over 1. So the slope of BD right away would be negative 3. And right away that narrows it down to one of these two choices. Well, if I look at this, where does it look like it crosses the y-axis? Is it easy to tell? No. But all I'll do is take the point E, right? So I know the slope of this line is negative 3, and I know point E is on it, right? And point E has the coordinates, E has the coordinates 1, 0. So right away, y equals negative 3 times x minus x1 plus y1. And right away, that just ends up being choice B. Okay, so that is kind of like the point slope form that they're giving you. Okay, and the last problem here. Jane made an initial deposit to a savings account. Each week thereafter, she deposited a fixed amount to the account. The equation above models the amount A in dollars that Jane has deposited after T weekly deposits. According to the model, how many dollars was Jane's initial deposit, right? So right away here, right, this is a gridded response problem, so you're going to have to bubble in, right, the answer. It's not multiple choice. This is your slope. So that's your rate of change. This is your initial value or your y-intercept, which is at 0.15. So her initial deposit was $15.